So even before that, right, we were trying to, we wrote a sample program in Java. So let's try to understand that bit more, right? If you see the sample program here, whatever we wrote, right? In Java, you should understand that everything will be in a class, right? If you look at the syntax here, the name of the file and the name of the class should match, okay? And Java is a case sensitive language. When I say case sensitive language, this capital S and small s system.out, they are different, okay? They are not treated as same. I hope you guys understood, right, what is meant by a case sensitive language. Java is a case sensitive language, okay? Small letters and capital letters are treated differently. Like for example, you have hello, right? HELLO, H is capital, and if you write another, create another class with small h, HELLO with H as small letter, so both are different, okay? And in general, every class name, whatever we are just going to create in Java, it should start, the first letter should start with a capital letter. That's a general naming convention that we will be following. And every class, if you see, look at the line number 3, right? We are just creating a class hello, and then we are making it a public. So because end of the day, there is no point creating private class or private protected classes, okay? Because end of the day, the class is supposed to do something, and your other objects or your application want to make use of that class, right? So it's always public. Yeah, sorry, it's always public, right? And on the first name, if you see, you have a package declaration. This is nothing but it talks about the folder in which this particular class hello is, right? From source, it is in com Java training folder. Like if I just open this here, right? Show system explorer. So this is called a fully qualified name of your Java class. If you see here, src is the folder where all your code Java files will be there, okay? If I go to src folder, the first folder I have is com, and then Java. Inside com you have Java folder, and then you have training folder. Under that you have hello class. So that's what the package name is for. And that's what with respect to class is for. And inside class, you can put methods and variables, right? But if you look at this particular class, like if we were talking about animal class, right? So this particular class will just have some variables, and if at all we want, like let's take this dog method, right? So it has these variables which are also called as data members, and then we have something called methods, right? But if you look at this particular class, it has a method called main, right? And the signature is a bit different. I mean, void, it has something called void, and it's public, it's static. And then string args, it has some input arguments called string array, okay? And inside that we have some code that we write. Here we wrote some system.out.println, which is basically to print this output onto the console, right? But what is this particular special method is, in Java, main method basically acts as entry point of your application, okay? Suppose let's take this Java course, okay? In this, we created so many classes: animal, box, demo, hello, mammal, poodle, right? So which class will execute first of all this, right? So basically, basically a Java will find for this public static void method which is present in any class. So it's obviously present in hello class, so it will start its execution from hello class, okay? That's how it is. So your main method basically acts as an entry point for your Java application, okay? So if you look at the methods of dog class, you have public and string, right? Public string and fetching, this fetching method, because here this fetching method would return a value of string value. That's why we typed the string here. If you look at the barking method, it is not returning any value. So we had a void. So that if you see here, the main method will also not return anything to the caller. So that's why its return type is void, and it's public because it's an entry point. Execution has to start from there. Your JVM has to execute your Java application from this particular point, right? So it should be able to access this method. That's why it is public. So this is a predefined method signature. Okay, this is called method signature. And why static is because it has to be static in the sense end of the day, any code you wrote, it has to be loaded into your memory to execute. Okay, static will automatically load it when your JVM or Java application, when it is starting up, it will load this particular static method code into your memory so that your JVM can execute it, right? But whereas for doc class and all, these are not needed to load into memory immediately, right? I hope you understood the point I'm trying to convey. Suppose you have 100,000 applications, right? 100,000 Java classes, for example, right? You don't want every Java class to be loaded into the memory at once your application is up, right? Because you may not be using all 100,000 classes at once, Java class at once. You might be using maybe 10 initially, and rest on demand basis you would be using, right? So when you need to use this, you can allocate Java memory for them, right? And when the usage is finished, you can clear the memory, right? So in that way, these methods are not static because these are not needed at the initial time because they don't act as entry points. Since your main method acts as entry point, that's why we have a static keyword here telling. So this is a standard signature. Okay, so any Java program you want to execute immediately then and there, you go with this particular main method, public static void main string arguments. And you can also pass some arguments to this method, command line arguments, which will be stored as a string array and which we would be storing it. Okay, like this main method can take these arguments, a string array. It can take. What is this string array? If you see this notation, string, you know, right? It will hold a text values. What is this particular notation? Array. This is called array notation. String array is nothing but it will contain multiple strings, not just one string. Okay, it will contain multiple strings. So that's why we are representing it as an array. Okay, so this is what the basic program of Java, right? And if you like I said, right, the Java program is Java programming language is completely case sensitive, right? There is a clear difference between, and your Java programming language uses a lot of keywords, right? If you see, this static is a keyword, void is a keyword, predefined names your Java language is actually using, right? Class is a keyword, package is a keyword, public is a keyword, right? And if you see here, private is a keyword, string is a keyword, boolean, return is a keyword, right? And then if you see mammal, extends is a keyword, int is a keyword, right? So all these are keywords. A lot of keywords your Java programming uses, a predefined text names keywords, right? For it to identify. And having said that, in a nutshell, your Java language is a strongly typed language. And that is what adds the safety and robustness when it comes to Java expression language. So basically, what is meant by strongly typed language, right? If you see this doc class, how many variables we have here? How many variables we have here, guys?
5. 4, sorry.
Four variables, right? And for every variables, we define something called a data type, right? Your name is some data and we define some data type, right? String, yes or no? So this is mandatory in Java, okay? You can't create a variable like say private, I will say age of dog. You can't do this because Java is strongly typed language. You have to define the data type also. Age is a number, right? So you have something called data type, integer data type. So Java is a strongly typed language. For every variable that we deal with Java, you have to put the type of that variable, like which kind of data will be stored in that variable, whether it is a string like a text value or it's an integer value like int, and then Boolean values, right? Boolean we discussed, it's just simply true or false. So you have to be like really careful when you assign some values, right? For example, you said age is an integer, and you can't assign a string value to integer like this. Okay, this is illegal. See, if you see, it is throwing an error here, right? It is throwing an error here. Okay, so this is not possible. Okay, if you declared age as an integer, then you should be putting age. Okay, like let me just add that here. Okay, no, this is illegal. Okay, you see the error. Change type of age to string, because we are assigning string value, but we are saying age is integer value. So this is illegal. Okay, you shouldn't be doing this. So the value will be this. This will work when you put some integer value. Okay, so that's what when I mean so this is basically a type mismatch, right? You're saying age is an integer value, and you're trying to put a string value, so which is basically type mismatch. And in these cases, at compile time itself, we would be seeing some errors like what we just saw right now, right? And in Java, there are a lot of different data types, okay, based on the based on the type of data we are storing into that variable. Okay, first of all, what are variables? Like if you see in this particular doc class, these first 5 parameters like name, breed, color, hungry, age, these are variables. Variable is nothing but, as the name suggests, something that varies, right? Like typically your doc can have some name initially, and it can be changed at a later point. It can be reassigned. So that's what these are called variables. Okay, so I told, right, these are called data members or instance variables, the state of your particular object. So these are called the variables in Java, right? And your methods will work to modify these variables, right? They tend to modify the state, right? Your behavior, which is basically your method, right? And these particular variables in Java, we have typically 8 primitive types, data types. Okay, 8. They are called primitive types. So one is, and they are broadly divided into these categories. Okay, integers, floating point numbers, characters, boolean. And if you see integer, this group includes byte, short, int, and long. And then floating point numbers, float and double. Characters, just it includes something called char data type. Boolean is nothing but it includes the boolean. Okay, the simple boolean. So these are the 4 primitive data types that are available in Java, right? And another one is the string, which string is not a primitive type. It's an object, like we will discuss that. But in general, these are the 8 primitives that we have, right? Byte, short, int, long, char, float, double, and boolean. Okay, it comes to 8, right? So why in integer, why we have these many types? To store numbers 1 to 8, we could just have one, right? Why we have these many numbers, these many data types, right? So basically, if we try to look from a memory standpoint of view, right? On the back end of the day, your computer knows one language, which is a binary language. What is binary language? It will just understand zeros and ones. It will not understand English alphabets, right? Your computer machine, it will not understand English alphabets. It knows only one language, which is binary language. Okay, which is basically, binary means 2 by 2, which is basically ones and zeros. And it follows this octa type notation to for example store a particular value in a memory, right? See, end of the day, this data, whatever we are trying to create, everything has to be stored inside memory, right? And right, so typically I'm just explaining about integers along, right? This particular integers along. So when it comes to these integers, right? All these four types, all these are signed, okay? They contain positive and negative values, and positive and negative integers, like for example 1, -1, both are supported to store in this type of variables, okay? But what exactly is the difference between them is the type of bits they accommodate, or bytes they accommodate, okay? Let's start with byte, okay? This byte will contain 8 bits, okay? So what is that 8 bit? So byte is containing 8 bits, right? P8, in general, in computer, these are all basically the byte bits. These are terminologies that if you studied the computer course, right, be it in your graduation or somewhere, like you would definitely see these bits, bytes, and how the computers would store data, right? So you would understand that. So like I'll just give you a small intro here, not much. I'm not going to dwell much into it. Okay. So in typical, normally a byte will have a memory capacity of 1 byte basically, right? And 1 byte is 8 bits. 8 bits in the sense it contains the 8 notation of the binary, okay? And which is nothing but it would contain something like this, okay? 8 bits in the sense 1, 2, 3, 4, 5, 6, 7, 8, okay? And it will contain from 2 to 2 power 0, like 2 power 0, right? And then 2 power 1, and then 2 power 0, 2 power 1, 2 power 2, 2 power 3, and so on, and 2 power 4, 2 power 5, 2 power 6, 2 power 7, right? What is 2 power 0? What is 2 power 0, guys? To the power of
1,
0, right? Okay. And 2 to the power of 1? 2 to the power of 2?
4,
2 to the power of 3?
8,
2 to the power of 4?
16,
2 to the power of 5, 32, 2 to the power of 6,
64,
64, 2 to the power of 7,
128.
120. Okay. So this is how your computer basically stores data, okay? So basically if you see, these are 8 digits, right? 1, 2, 3, 4, 5, 6, 7, 8. So that means your 1 byte 8 bits hold a value like this, where you would enable each value using these bits. If it is 1, we would take this value into consideration, okay? When I said binary language, it is ones and zeros, okay? Now let's see how we can represent a certain value in a binary format, okay? Let's give a number. Let's talk about 8. How can we represent a value 8, integer 8 in binary format? This is how it represents. So 0, 0, 0, 1, 0, 0, 0. Okay, if you see here, 1 is 0, 2 is 0, 4 is 0, but under 8 we have 1. So this is the binary representation of 8. When I ask you binary representation of 8, this is what we do, okay? We say 0, 0, 0, 4 zeros, 1, 3 zeros. This is the binary representation. And similarly, if we talk about binary representation of 6, how will you do it? Can you guys tell? 6. Come on, give it a try. Like whatever number it's not matching or more than that, we'll just simply put 0, right? 120 is a very big compared to 0, compared to 6, so we'll put 0. 64 is also 0, 64 is also 0, 16 is 0, 8 is also greater than 6, so we can put 0 here. Now I
1.
want 6, right? So under 4 I will put 1, and under 2 also I will put 1. 4 plus 2 is 6, right? So this is the binary representation of 6. So basically, whenever you use integer 8 in your computer program, in the memory, your computer will be storing in this format, because your computer understands the this binary language, okay, zeros and ones, and in the underneath your memory would be divided into bytes, okay, and every byte is containing 8 bits, right? 8 bits, right? So normally, you know, right, we talk about 1 megabyte, 2 gigabytes, right? Normally we ask you, right, what is the memory of your computer, guys? What is the memory of your computer or mobile? We talk about RAM, right? What is the RAM?
6 GB.
6 GB, right? So that means equal to approximately 6 gigabytes, right? And 6 gigabytes equal to how much megabytes?
6 times 1024.
6 into 1024 into megabytes, right? MBs. And your megabytes equal to how many bytes? Kilobytes?
Maybe another 1024.
1024.
6 into 1024 into 1024 kilobytes. And this would equal to how many bytes? Okay, byte is, we are coming to this only. Okay, it is 6 into 6, 6 into 1024 into 1024 into 1024 bytes. Okay, so that means whenever you say you have 6 GB memory, you are having 6 into 1024 into 1024, this much bytes. And this equal to how many bits? You just multiply it with 8 again. Okay, 6 into 1024 into 1024 into 1024 into 8. So that means this much memory spaces you have, right, to store data, right? When your computer is storing digits like this in the 6 GB RAM, so your computer uses RAM only to store your, when it executes your computer programs, right? It basically uses RAM. It will not uses your hard disk space, which is outside of your memory, okay? And your RAM is highly volatile, because your CPU can read something from RAM quickly than your hard disk, okay? So that's why for computer programs to execute faster, this RAM memory is designed, because it has a very sophisticated retrieval and storage mechanisms, right? CPU basically executes instructions in milliseconds, like 0.00000 seconds. It will execute instructions that fast. That much fast it will execute this instruction. So normal hard disk memory, it won't support that much sophisticated operations. So that's why you created a RAM, a special memory, which would have very random access. RAM is nothing but random access memory, right? It's a super fast and highly sophisticated memory, which would support random access array at very high speeds, right? So and it's costly also. That's the reason you have 10 GB of RAM, which would typically, or 6 GB of RAM, and your hard disk space like 500 GB or terabyte to store your data, right? Your data you will not be storing in memory. Your RAM is basically used by your computer programs to execute these things, to execute the instructions of your computer, right? Like suppose I'm opening this paint tool, P brush, right? So in RAM, this P brush occupies certain memory for it to work. Okay, so that's how it is. So when you say 6 GB memory, that means you have this many bytes, sorry, bits. Okay, so and holding to this capacity, you can store these digits like this. So in general, this is what your computer stores. Okay, computer stores your data in form of this binary zeros and ones. This is all some graduation computer subject gyan, okay? So like don't just understand this, okay? No need to delve into much further, okay? Having said that, why I said this is because your byte will support 8 bits, okay? Your byte is like the smallest integer type. It is like simply 1 byte is nothing but it will support 1 byte. That means it will support at max 8 bits. So that means in a byte you can store integer value from to a max range of 128. Okay, you're getting me, right? So when I say 1 byte, you can what is the biggest number that we can store in a byte is 128. Okay, so it is because since it is a signed number, 1 bit will be used to store the sign, whether it is plus or minus and all, right? So your byte will hold numbers ranging from -128 to 127. Okay, so that means if you put 128 or 130, 140, your byte will not be able to store that because it has bits, 8 bits only. To store the bigger numbers, it needs more bits, right? So your byte is designed to have only 1 byte. It's the smallest integer, so it can store values up to 127. Okay, whereas your short, right? Next comes the short. So it is like a 16-bit type, right? Double of byte. Your byte is basically 8 bits, whereas your short is 2 bytes. So that means your short has 16 bits. So 16 bits, that means it can store integers of range something like this, minus 32,768 to 32,767. Okay, so it can store integer value, the maximum integer value your the other short data type can store is 32,767. So anything beyond 32,767 you cannot definitely store them in a short. Then you have an integer type, okay, which is basically, so this is 8-bit, this is 16-bit, and now this is 32-bit. Okay, and you 32-bit in the sense, so when I say 16-bit, it can store values from -2 to the power of 16, -2 to the power of 16 to +2 to the power of 16. That is the range it can use. Okay, when I say integer 32, the same, right? It can use -2 to the power of 32 to +2 to the power of 32. That's the range it can store. And the highest number that you can store in an integer is 2147 and 48, and 647. Okay, this should be the value. This is the value of 2 to the power of 32. Okay, so this is the maximum positive integer that can be stored in an int. And similarly, you have long also. Okay, long, which next integer type is data type is long. So this is 8 bits, this is 16, this is 32, and long will store 64-bit data. Okay, so it can store 64-bit length numbers, which are like pretty huge. Okay, understood, right? Any queries on this? Okay, now what are the floating point numbers, right? Floating point numbers, they'll store the real numbers, right? What is real number? Just mathematics. This is simple mathematics. Floating point numbers are used to store real numbers. What is a real number? Come on, guys. Anyone from mathematics background? Here 1, 2, 3, 4, 6, 8 are called real numbers, whereas numbers like 1.2, right? Points 3.24, 5.687. Okay, minus 0.5 minus 0.24. Okay, so these are called what? These are called real numbers, right? And also called as floating point numbers. Okay, and in general we have two types. Okay, float and double. Your float is 32-bit, whereas your double is 64-bit. So accordingly they will have certain ranges, right? Float means they'll support only single precision in the sense after point it will take only one digit float. Okay, whereas your double, it will take double precision. That means it will accept 2 values, 3 values, and so on. Okay, that's the only key difference between float and double. Okay, they accept real numbers, right? Like 1.2, 1.3 point, like those kind of numbers. And float will accept single precision, and your double will have double precision, right? Which is like more than one value, sort of, right? After the point. So that's what with respect to floating point data numbers. Okay, next you have char. Char is nothing but a char is like a character, right? English alphabets A, B, C, and so on, right? And for example, your character C, it will be stored in a format called ASCII numbers. Okay, ASCII. So there is a lot of jargon that's coming. Okay, ASCII, like people who are from computers background in their graduation, they must understand this. Okay, so again I told you, right, computer end of the day stores data in zeros and ones, right? But how can we store English alphabets is the question now, like A, B, C, and so on, right? A, C, D, and all. So how computer stores these kind of letters, English alphabet, is in general in any language alphabets, not just English, can be any language, right? So internally computer represents, computer uses this ASCII convention. Okay, ASCII convention is nothing but every character is represented with certain number. Okay, for example, A is represented with a number like 65 or 63. Okay, capital A, and small a is represented with another integer. And once you represent these numbers with integer, internally you can convert that integer into bytes format and store it, right? So that's how your computer basically stores these values. Okay, for example, let me just give it a try here. Let me just show you something. Okay, here let's take one character variable, character C, and I'm storing some number like 65. Okay, this is fine because internally 65 is nothing but the ASCII code of a particular alphabet. Okay, if I try to print this C value, what C value? Okay, if I try to print this, let's see what we are getting. Okay, if you see C is capital A, right? What if C is 32? There is nothing for 32. I think it's space, empty space is 32. Okay, empty space, you know, right? Space character like this. Okay, and if you put 31, let's see. So likewise, right, this is 31 also, nothing's coming with. Why? Let's take another number. 65 we give, right? 66, let's just 66 is B, fine, but one. Okay, it has this character, some question mark character. Okay, like 2 if you see. So likewise, right? So internally these alphabets are represented with let me just run this. 2 contains this 33 again. Let me just run. Okay, 33 contains this asterisk, exclamation mark. Sorry, not asterisk. Okay, exclamation mark. So likewise, all your English alphabets, and not just English, all your letters of your language are stored in this ASCII format. Okay, and Java in general uses something called Unicode conversion. That is a different standard like ASCII. but idea is to store these numbers in a integers format. Okay, you map each number with an integer so that you can store these characters in a memory. Okay, and in general, the char, right, it is 8 bits wide. Okay, it is 8 bits. That means they contain 1 bit, and but in Java it is of 16 bit. I think it's not 8 bit. In C, C++ it is 8 bits, which is basically 1 byte. But in Java, your character is 16 bit, and Java uses Unicode representation. Okay, Unicode, that's something we'll talk later. But Unicode representation, it won't use ASCII. Okay, I just gave this as an example. And when I said 16 bit, the range of char in C is from 0 to 16 bit, right? So it will come somewhere around 65,536. Okay, so this is the range of character, right? And when I said ASCII, right, it ranges from 0 to 127. This is like the standard set of characters. Okay, and then you have a Latin, another character set like ISO, Latin, Unicode. These are different character standards. Okay, so which is out of scope, we'll not discuss much now, but just remember these jargons. Okay, its range is from 0 to 25. 0 to 27 is ASCII standard. Okay, and this is the Java's Unicode standard. Unicode, UNICODE, Unicode standard. So likewise, right, we kind of we kind of convert these characters into the respective integers, right, using these bits and all. And not just Unicode, it just has a lot of global portability, right? That Unicode representation not just adopts English languages, it also adopts German, Spanish, French, many other foreign languages, right? It can keep adopting, right? So that's why Java uses the powerful Unicode. Okay, now having said that, that's all with respect to the character, right? And the Boolean, it's pretty straightforward. Boolean is nothing but, Boolean is what? It's just true or false, right? And it will just contain either true value or a false value. Okay, true or false, as simple as that. Nothing much in it, right? And then we'll talk about the next concept, type conversion and casting, right? So basically, what is type conversion and casting? I think we just saw this sometime back. We were just trying to assign a string value into an integer, and we looked at it, and it was clearly throwing some error, right? Type conversion means we are just simply saying like this. Okay, suppose I am creating one integer value. Okay, integer 100. I'll take this one variable I am creating. Okay, integer. I'll say sample val equal to 100. I created one variable. Now I am creating another variable long. When I am saying this value 1. Okay, and I can do like this, right? Because the value 100, I am storing it in a val1, which is of long type. So that means here it may be using just simple 32-bit, but here I'm trying to store it in 16-bit. Here I'm just assigning it to val1. Since they belong to the same category of integers, this type conversion will happen automatically. This is converting type. So we are converting the type of 100 from integer to long, right? So this is called type conversion in Java. So if here int and long are compatible types. Compatible types in the sense they belong to the same integer category. So this will happen automatically. This is not a problem. Okay, but suppose if you try to put a floating number into integer, let's just see that. Okay, I'll take a float and I'll say a value which is 3.14, something like this. Okay, so you see here, right? So this 3.14 is a float and this is called casting. Okay, I'm saying this is a float variable. Suppose now I'll take the long again, val1, and I'll try to assign a pi. Look at the error. What is the error? Cannot convert from float to long. Okay, because here it didn't throw error because your integer and long, they belong to the same type, right? Same category, integers, but whereas your float is in other category. So to make it work like this, right? To convert a pi value into a long value, integer value, you should do something called casting. So here we will simply say we'll use casting. Like the moment I put this, see the error is gone. Okay, so that means now your value will contain, it will contain only 3. It will not contain 3.14. Okay, because your long will not store anything after point, right? So it will ignore this. When we do cast, right, it will ignore this. So your val will finally contain value 3. Let's just see that. We'll print val1 and I'm executing this. It contains 3, right? It doesn't contain the value of 3.14. But if you type pi, it would contain the 3.14 because your long doesn't store this real numbers, right? Point numbers, right? So that's the difference. And this method, like when you convert one type into another type, here we are trying to convert long, float into a long. So to make it work, we have to do a casting, right? Type casting, and you do type casting like this. So this pi value, which is float, we are saying we want to convert it into long, right? So, and the type conversion happens automatically, right? And like if I said, if both belong to the same compatible type, right? Like long and int, then here you don't need to explicitly put long like this. Here it is automatic. Java takes care of that automatic type conversion if they belong to the same group. And same case here also. We can float to double, double to float. Your Java takes care of it. Okay, but this integer to float, you need to explicitly typecast like this. Okay. Any queries here? This is a small concept of typecasting which I want to discuss at this moment. Okay. But we will be discussing more when you do hands-on of more programming, right? We'll just come across a lot of techniques here. Okay. Any queries here, guys, on type conversion and casting? Automatic type conversion and casting. Okay. And you can convert the string types also to integer and all. Okay, for that we have a different technique which we will talk at later point. Okay, now we will talk about the next concepts, arrays, right? So base is vertically array. Array is nothing but it's a group of variables, right? And that variables should be of same data type. So that means I can create an array like this. Okay, suppose integer, okay, and I'll say I'll take some name like array arr equal to, I'll use this new operator. Okay, so let me just first declare it integer like this. Okay, this is an array. Okay, so array means it will in your memory it will store a group of integers like this. Okay, it will store like this. It will store okay, it will store in this format. Okay, and in integer, since I said this is an integer array, right? If you look at this array is an integer array, that means I can store this, every box is like one array index. Okay, so in every box I can store one integer. So that means every box is accommodating one integer, which means 16 bits. Okay, 2 bytes basically. sorry, not 2, I think 32, right? It is 32. So it will accommodate 32 bytes. Okay. So 32 bits, right? Basically 4 bytes. And here we can store multiple numbers in an array. Like I'll store a value like 2 here. And then in this box, I'll store 3, and this box I'll store 6, and this box I will store 8, like this. Okay. So in our array, we can store multiple values. Okay. And here the size of our array is, size is nothing but how many elements we are storing in our array. Here we are storing 4 elements. So the size of our array is basically 4 here. Okay. And this particular array is of type int, right? So let's see how we can create an array, right? So in Java, we have something called a new operator. Okay. Using the moment I use new keyword, NEW. Okay. Let me just type NEW, new. And I should also tell the size of array I want to use. Okay. I want to use, integer array, and let's say the size is 5. That means in this array integer, it can store up to 5 integers. Okay. So this new is nothing but this new keyword. This is a new keyword in Java. Okay. I think we already saw that the other day when we were trying to create objects, right? So new keyword is basically used to create memory. So when I put new, it will allocate a memory for this array integer. Okay. In your RAM, right? It will allocate a memory for this array, and it will store the values of array there. And when I say array, it would be stored in a contiguous, it's a linear data structure. When I say linear data structure, in your memory, right, you will have a RAM like this with lots of columns, rows, layout like this. Okay. So, okay, let me just put it this way. Ensure this is your 6 GB RAM, right? It will have a lot of columns and rows like this. This is how your memory is kind of divided into chunks. Okay. It will be divided like this. Okay. And when I say my array size is 5, right, it will be stored in a contiguous memory location. Contiguous memory location in the sense, it will start at suppose if start at this block, if it starts of memory, right, it needs 5 blocks to store, right? So it will take 1, 2, 3, 4, 5. Okay. So it will take these 5, it will take. So that means it will use contiguous memory. It's not like when I say array size is 5, it will store one, it needs 5 boxes, right? It will store one value here, it will store another here, it will store another here, it will not store another here. This is not how your array stores data. It stores data in a linear format like this, in a contiguous memory location, right? And when I said 5, it takes that 5 boxes and it will store the data there, right? And how I can actually store the data now. Okay, I created an array. Now how I can actually store the data? You store the data using something called array index. Okay, so using 0, like say for example, I'm storing value 20 here, and then ARR of 1. Okay, I'll say 30, ARR of, I'll just copy this. Okay, 2, 3, and 4. I think that's all. 5 elements are done, right? Here 20, 30. I can store 16, 100. Again some 73. Okay. So if you see here, my array size is 5, and I have stored here 1, 2, 3, 4, 5. But if you see the index 0, 1, 2, 3. So that means whenever my array is stored in a contiguous memory locations like this, right? This boxes like this. So it uses index-based mechanisms to store and retrieve values. Index-based in the sense, you have these 5 boxes, right? It will start assigning indexes starting from 0. The first box index is 0, second box index is 1, third box index is 2, and then 3. So that means 4. So basically, if your array has size 5, it will have indexes ranging from 0, 1, 2, 3, 4 till 5 minus 1, right? 4. That will be the maximum index. So typically, similarly, like that, if your array size is n, then your index size will be from 0 to n minus 1, right? We can say that, right? If our array size is n can be anything, right? If our array size is n, right? The indexes can range from 0 to n minus 1. So here our array size is 5, right? 1, 2, 3, 4, 5. So the indexes are ranging from 0 to 5. 0 to 5 minus 1, which is 4. Okay. When you access 5, it's not available. So it will throw some exception. Okay. So now I created some values like this, and let's just try to print that array. Okay. I'm just printing that array. Let's see what you get. So this is printing a memory address. Okay. But if you want to print these, we use something called for loop, which I'll show you. If you see, look at when I printed an array, it printed something. What is this actually? If you see, it printed something. This is the, I said, right, your memory is divided into rows and blocks, right? So this is the address at which your array is stored. Okay, this one. This is a hexadecimal address. This is called hexadecimal address, and in your memory, every location will have some certain address, memory address, okay, like your RAM, and this is the address in which your computer is basically storing this particular array which we created here, right? This ARR array which contains 5 integers. And if you see, the values should be of same type. Since we said this is an array integer, it should only hold array integer. It should not have values like float numbers like 73.2 or character values like C. It can't hold these values. Okay, understood, right? It has to be of same data type. So this is what array is. Your array is a linear data structure, and it will store values of same type, and size has to be mentioned at first, and it will use index based mechanisms to store and retrieve the data. Okay, so that's all, guys. Any question here? Any question on this arrays? Any questions, guys? This is a single array which we created. Okay, we also create multi-dimensional arrays in Java like this. Okay, like a matrix based, right? I'll put double like this. So double like this. I'll say 5 and 3. So that means this is like a row and column storage types. Okay, like R1. So when I say this, it will create 5 rows and 3 columns of data structure, something like this. Okay, it will create a box. I'll just remove this. So it will create 5 rows. Okay, 1, 2, 3, 4, right? You have 5 rows now. 1, 2, 3, 4, 5, and you have 3 columns. 1, 2, 3. Okay, this is the box it will create, right? And when I say 5 of 3, and this will also contain indexes like this, right? Your row indexes will be 0, 0, and 1, 2, 3, and 4. Okay, so it will contain like this, and your column indexes will be 0, 1, 2. Okay, if you want to access this element, it is in first row, second column, right? So you would say something like this: array of, if your array name is A, you can put A of 0 and you will say A of 2. Okay, this would access the element from here. Okay, so you use both row and column based indexes to retrieve that value, and at the same time to store something. These are called multi-dimensional arrays, 2-dimension arrays, and you also have This is also three-dimensional arrays. Arrays will not get into much that, but just understand array is a sort of a special data type which would store multiple values of same data type, right? Either it would store all integers or all characters or all float. It won't store mix and match, and it will use this index based mechanism, and in the memory it will store this data in a contiguous memory. It starts at one point and it kind of ends there, right? So that's what it is. And you can also declare array in a single line like this. Okay, I showed you this method. You can also do simple like this. Okay, you just do you can use something like this, like I'll say 5 1 2 3 4 5. Okay, this is also a valid declaration. So this is also a valid declaration. Okay, I think size is not required. It will automatically. So this is how also you can. We already created array, right? That's what's throwing an array. Okay, array 2. So this is also you can create an array. So if you look at this, it contains these values 1 2 3 4 5 arrays. So your array size is 5 here, which we are not mentioning. Okay. So when you do this also, it will in memory, it will store this array, right? Okay. So that's it. I think we'll stop here for today. Any questions, guys?